Hey guys, I'm back with another exponential math video relating to the ACT. It's the second one out of the series that I've made. The questions I've chosen between both of these videos really span a number of different years that the ACT has published these types of questions. So it will definitely give you a good insight to how they have created exponential questions over the years. Now, hopefully that will be really helpful to you. With that being in mind, please remember we're always looking for young adults who need help outside of school, that just don't have the ability to get help outside of school. So please like, share, and subscribe to help us find these young people, and hopefully we'll be of a help to them. Let's get moving on to question number one. Okay. So the first question we have is, you see a complex equation here. And when you look at the answers, you know they're simplified. So let's go ahead and simplify this ugly looking monster. Let me get my pen tip set up. There we go. What just happened? All right. So 8x to the 5th times y to the 4th times 6x to the 13th y cubed divided by 16x to the 6th y to the 14th. So let's go ahead and multiply the numerator together. The two terms, the numerators together. So 8 times 6 is 48. And then x to the 5th times x to the 13th is x to the 18th. And then y to the 4th times y cubed is going to be y to the 7th. That's divided by 16, x to the 6th, y to the 14th. Now we can reduce 48 and 16 down to 3 over 1. And that's going to permit us to go to our variable x to the 18th and x to the 6th. Now remember, when we have the same bases and we're dividing, we subtract exponents. And so 18 minus 6 is 12. And we're going to put that in the numerator because 18 is larger than 6. Now look at y. We're going to do just the opposite. 7 is smaller than 14, and 14 is in the bottom. So we're going to subtract down and say 14 minus 7 is 7. So we should end up with 3x to the 12th divided by y to the 7th. And that's going to give us answer choice J. For how many integers x is the equation 3 raised to the x plus 1 equal to 9 raised to x minus 2? So there's something really unique here that will help you. So 3 raised to the x plus 1 is equal to 9 raised to the x minus 2. Now, 9 has multiples of 3 in it, and we're playing with exponentials. So let's rewrite 9 as 3 squared and raise it to the power x minus 2. Now notice my exponentials are in the same base of 3. So let's clean up the right side and raise 2 to the x minus 2 power. So multiply them together and say 3 raised to the 2x minus 4. Now we can go ahead and eliminate the bases and pull out the exponential or the power portion of it, if you want to call it, and set it equal to one another and solve for x. Well, I'm going to subtract over an x and I'm going to add a 4 to the other side. So I'm going to get 4 plus 1 is equal to 2x minus x. 2x minus x is just x. 4 plus 1 is 5. Now, look at the question. How many integers x is the equation true for? Well, there's only one, and that's the integer number 5. So it's going to be answer choice B as in boy. C. Let's see. What's next? So if x is a real number such that x cubed is equal to 64, then x squared plus the square root of x must be equal to what? Well, they're giving us a hint what x is by using x cubed being equal to 64. So what number can we put in for the base that's going to give us a 64 when we cube it? Well, 4. So 4 cubed is equal to 64. Okay. Now we know what x is. So that was step 1. So step 2, let's take x squared plus the square root of x. Let's substitute 4 in for each x in this equation in step 2. So 4 squared plus the square root of 4. So 4 squared is 16 plus. Now, when you take the square root of 4, you really get plus or minus 2, right? Now, 16 plus 2 will give us 18, or 16 minus 2 will give us 14. Which one of these answers do we have in our answer choices? We have 18, which is answer choice H. Okay. Well, let's see what the next one is. Consider all pairs of positive integers W and Z whose sum is 5. So let's stop right there. So the first thing that we see, W and Z, or W plus Z, must be equal to 5. Because they're telling us the sum. Okay, let's go to the next sentence. For how many values of W does there exist a positive integer x that satisfies both, all right, second part, 2 to the W is equal to x, and x squared is equal to 64. Okay. Or is that Z? That's a Z, sorry. I apologize. My glasses are not strong enough anymore. All right, so x to the Z is equal to 64. So we know x is equal to 2W. So let's replace that into x raised to the Z power, or substitute it in there, in other words. 2 to the W raised to the Z is equal to 64. Well, that's really saying 2 raised to the W times Z is equal to 64. So what number do we need W times Z to be to give us 64? So W times Z needs to work out to be 6. Because 2 to the 6th is equal to 64. That's 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 2 times 2 is 4. 4 times 2 would be 8. 8 times 2 is 16. 16 times 2 is 32. And then 32 times 2 is 64. So we need the W and Z to be able to multiply together to give us a 6. Okay, so what numbers can we use for W and Z to be multiplied together to give us a 6? So, and the other thing is, other issue here is we have statement number 1 that W plus Z must equal 5. So we're limited by statement 1. With that being brought to our attention, that means we got to use two numbers that's going to coincide, but to add together to give 5, but yet multiply together to give us 6, right? So 3 times 2 would give us a 6. And 3 plus 2 gives us a 5. So if we call that W and Z here, so W representing 3 and Z representing 2, it could be vice versa. 2 times 3 would give us a 6. So those are the two that will multiply together to give us 6, but also add together to give us 5. Now, for how many values of W does there exist a positive number, X, that satisfies both of those equations together? Well, there's only 2. So the answer choice would be B. Get that out of the way. All right. What is the set of all the values of B that satisfy the equation x cubed raised to the power of 4 minus b squared equal to 1 for all non-zero values of x? Well, let's just rewrite this here to make this clear. X cubed raised to the power of 4 minus b squared is equal to 1. Now, remember this, we're always, in this case, we're working with exponential ideologies. And so begin to think about how can I rewrite 1 with the idea of exponents. So I can rewrite 1 by saying x to the 0 power. Now I've got 1 into the exponential format. Let's clean up the left side now. So this is going to be 3 times 4 minus b squared. So x raised to the 3 times 4 minus b squared. Since I have both of these in the same base, I can pull out my powers and begin to solve for b. So 3 times 4 minus b squared is equal to 0. Well, we can divide by 3, and that's going to leave us 4 minus b squared. 0 divided by 3, which is going to give us a 0. Now, I'm going to move my b squared to the right side, and that's going to be 4 is equal to b squared. That's b squared, that's not b, so we need to take the square root of both sides. So that's going to leave us b, and that's going to leave us 2. Now, b can be actually plus or minus 2, right? So therefore, the answer choice will be K. This is a key idea right here that the ACT loves to put into their ideologies when creating these questions. So please, please be on your toes for that. Okay, number 60, which is going to be our last one. And it's a little sneaky. And I don't know how fair this really is to most of the young adults that's going to be taking this exam. It's very questionable, in my opinion. So let m and n be non-zero real numbers such that 2 raised to the n plus 1 is equal to 2m. Which of the following is an expression for 2 raised to the n, what is that, n plus 3? In terms of m. Okay. There's a relationship here. So notice we have 2 raised to the n plus 1 equal to 2m. And then we have 2 raised to the n plus 3. So 2 raised to the n plus 1 can be seen as part of 2 raised to the n plus 3. N plus 1, n plus 3. There's a relationship here. So what I'm going to do is I'm going to rewrite this. And I'm going to say 2 raised to n plus 1 plus 2. Technically, 2 raised to the n plus 1 plus the additional 2 fits this idea of 2 raised to the n plus 3. Now, this can be written as 2 to the n plus 1 times 2 squared. Now notice, 2 to the n plus 1 is equal to 2m. So we can replace this with 2m. And 2 squared is 4. So 4 times 2 is 8 times m. Now we have it rewritten in terms of m, which is answer choice K. Okay. These are, a couple of these are very sneaky, and I really don't know how many people could have really gotten number 60 correct. I would really like to see the data for that particular math exam to see how many people actually missed that question nationwide when that question was given. It would be very interesting to see. I assume a lot of people missed it. However, let's not be negative. Let's pray a lot of people got it right. With that being said, guys, I hope some of these questions have helped you. And I know the exams are coming up here in the next couple of weeks. So whichever one you're taking, ACT or SAT, I wish you all the best. Please remain focused. During the exam, don't check the clock too much. Don't let the clock become a distraction. Keep that under control so you can stay focused on the exam. And with that in mind, good luck to you all.